Today's webinar is going to be on critical minerals, creating jobs in the Williston Basin. So to start, again, this is being done through project funding of the Williston Basin Carbon Ore Rare Earth Element Critical Mineral Initiative, or CORE-CM Initiative. And quickly want to give a thank you out to all of the sponsors of that program, the Department of Energy, the Industrial Commission of North Dakota, through the Lignite Research Development and Management Marketing Program, Basin Electric Power Cooperative, BNI Energy, Minn Kota Power Cooperative, North American Coal, and Current Chemicals, who are also providing consultation through the course of the project. So this is the fifth webinar in a series of webinars that we have been holding since well, pretty much a year ago, And so at the end of the presentation today, there will be the posting of the link where you can visit the CORE-CM website and actually view these. If you got in late, you might have missed the fact that we are recording today's session and have recorded the previous ones. So you can go to that website and view any of these presentations that have been given so far. So to kind of just go over a little bit of some of the things mentioned in the previous presentations, when we are talking about critical minerals, the term critical mineral is kind of an umbrella term to talk about quite a few things. So more specifically under critical minerals, you'll hear many folks talk about rare earth elements. And the reminder here is that rare earth elements, unlike the name, are not truly rare, but they're not concentrated. So it's not like you would expect if you were going out and looking for gold, where you'd find gold in nuggets or in flakes. The rare earth elements are distributed throughout the medium in which they are contained. And so they have to go through some sort of a separation and concentration process. The rare earth elements that are used, it's a suite of elements that we'll show here in a few slides later, but each of them have different uses. And so if we're talking about those elements, we'll specifically say rare earth elements. Otherwise, if we're talking about critical minerals, we're using it as a catch-all phrase for all of the other elements that fall within this realm of critical minerals, but that we're not calling out specifically. And this will be a little more clear if you're unfamiliar with this type of nomenclature in a couple of slides. So the big thing here is that critical minerals are important to our everyday lives. You have devices and equipment that you use today that rely very heavily on rare earth elements to function. And so our modern economy relies on it. And because of world markets, also play a role in our national security. One of the main challenges, of course, is that for the U.S., we rely on more than 80% of our rare earth elements from outside of our borders. And as you can see by the pie chart that just slid in, the vast majority of those suppliers of rare earth elements come from Asia. And so this on the world markets then also become kind of a political tool. And we have seen that a few times. And so it does threaten national security, especially with the demand that rare earth elements play in everyone's lives today. And so in this periodic table are highlighted those elements that fit under the umbrella of critical minerals. And so those that are in blue are considered the rare earth elements. Dark blue are the heavy rare earths, and the light blue are the light. Scandium and yttrium are not rare earth elements per se, but they fall in that category designation of rare earth elements. And then those items that are in gray are considered the other critical minerals. Now, again, we're saying critical minerals, but I'm showing you a periodic table of elements. Minerals is because, typically when you are mining these materials, the elements that are desired, you're not pulling out in most cases as a pure element. It's in a mineral form that is further refined into extracting that element that you're looking for. So we're calling them critical minerals, but we're actually talking about elements here at the end of the day. So then looking at these rare earth elements and critical minerals and where to get them, where they're found in the ground, certainly within the US that are usable. There are a few hard rock mines contained in the United States, but there's only a couple. And so with this program, certainly the focus has been on carbon ore. And we're even looking beyond carbon ore, which would be in the Williston Basin, would be lignite coal. We're going beyond that and looking at ways to not only extract those elements from coal, but even looking at coal ash. That is the material left over after coal is fired for electricity production. The rare earth elements can be concentrated in that ash, even more so than in the parent coal. So we're looking at ways to extract it from there. But even beyond those materials, we are looking at things like produced water in oil and gas production, and that there is a potential that there are some critical minerals that might be contained in that water that might be utilized. One that you may have heard of is lithium. Lithium is being looked at fairly readily in produced water. But even beyond that, with work that's being done in the North Dakota Geologic Survey, and certainly work being conducted at EERC, we're also finding that there are critical minerals that could be found in shales. And here listed are a couple of examples of those clays that are found within the region that also contain these critical minerals that might be available for extraction. And then finally, also what's being looked at are those coal seams that are perhaps too deep to be mineable. There are some thoughts, concepts, and technologies at play that are available that perhaps can be used to extract those critical minerals from those deposits without having to actually dig them up. And so those are things that are also being looked at in the general concepts of critical mineral extraction and production within the Williston Basin. And if we start to look at business concepts around critical mineral production in the Williston Basin, for one, we feel that the infrastructure is there. We have the highways, we have rail, and certainly we have access to ports directly to the east in Duluth, but even to the south in Texas and to the west out in Oregon and Washington State, which puts us in a good position to look at the business case for critical mineral production in the Williston Basin. But again, a lot of that is going to be based on the end user and the final products and how well the business model and what type of business model is defined for this type of new industry to be made. And so then when you're looking at going from coal, the carbon ore, all the way to a finished product, you can see on the right side of the slide are the basic steps going from mining. Once you mine the material, you then have to concentrate and separate those rare earth elements and then process them so that they are in an oxide form. You might not have to go to full elemental form for them. And then they go into manufacturing and ultimately end up in our finished goods. And then in our last webinar that was given, and I encourage any of you that weren't able to watch that to visit our website. Nolan Thaker from the College of Engineering Mines Research Institute did a very good job of stepping through the process of what it takes to go from lignite coal all the way to refined materials that go off to production. But in that, what he showed was that there are a multitude of steps that have to be undertaken to get it through that whole process. And there are many handoff points along the way to get it to a final product. And with that, because of these products and what they need, there are different purities. And then if you're trying to take it to further purity, there are many processing methods that come into play for this. And there are companies that are located across the US and really across the world that take care of a lot of these processes. Right now, even for rare earth elements and critical minerals that are extracted from locations in the US, they still have to be shipped overseas to China for further processing. And so certainly there is research being conducted to try and find ways to bring some of those steps back into the US. And of course, a lot of these steps do require chemical solvents and other processes to do the extraction. But if you can get it to a solid form, even in an oxide form, these are very easy and safe to transport long distances by truck or by rail or what have you. And then finally, another thing to point out in this, with all of these many steps and handoff points, anytime there is a solid produced within the process, that is the potential nexus of a business. And so there are a multitude of businesses, many dozen perhaps, that could be developed along this processing chain. So that is just a real brief, very brief overview of things that were covered in the previous webinars. And so with that, then I'm going to turn this over for today's discussion and hand this off to Dean Bangsund, who's a research scientist at the North Dakota State University in the Department of Agribusiness and Applied Economics. And so we were joking right before the start of this that yes, it is possible to get folks from North Dakota State University and the University of North Dakota to actually work together, and it works very well. And with that, I'll turn it over to Dean.
All right, thanks, John. It's a good thing we're not studying football or something like that. But I think John just covered the highlights of what we're learning with the CORE-CM project, and what's available in the Williston Basin, what it might take to extract it. What are some of the challenges that we're seeing in really developing an industry that doesn't exist? And questions have come up on, well, what would the industry employment response look like? Or what might we see for something along the lines of jobs or employment in North Dakota? So we're going to take a cursory look. Maybe bird's eye is too low in this case, maybe low Earth orbit. I don't know. It's a high look, but we're going to look and see what some of the job response might be in North Dakota based on some of the opportunities that we've looked at with the CORE-CM project to this point. I'm going to cover four things. One, what does it take to measure employment at an industry level? And there's a process in place for that. And we're going to cover that along with some concepts to help people understand what it is that we're discussing. And we're going to highlight several of the opportunities that we think are reasonably viable at this point in the understanding of critical minerals, and apply some employment numbers to those and look at what the response might be in the state. And we'll pull that together into a statewide estimates, and then we'll take a look at workforce. So hopefully by the time we're done, we'll get all four of those things covered. There's three concepts I think that are critical to understanding what do we mean by employment at an industry level. So we're talking about something that might influence jobs across the entire state of North Dakota. The first one is direct. We're going to use the example here that for some reason NDSU decided I wasn't employable, and so I got a new job at the EERC. And so that would be an example of the direct effect. That is the first change that occurs in the economy, the first round of a change. And that can be a job, it can be a change in salary, it can be a new business, it can be an expansion of an existing business, and so on. So then that's the first concept. The second one is indirect. What happens to the organization which employed me? They're going to have a sequence of things that they're going to do, which are then going to influence additional activity. This is what's called indirect. And this is an example here would be my presence at the ERC. They need to purchase some more electricity. Maybe there's some office supplies, some equipment, some travel along with my job, things like that. So that sets in motion another round of economic activity. It leads us to the third one, which is now that I have an income and I need to live. So I'm going to go out and I'm going to buy the goods and services that I would as an individual or as a household. And that sets in motion another series of effects in the economy that we call induced. So we'll take these three and we'll walk you through kind of what the process is, and then provide a few examples in a little greater detail. Typically, when we look at something at an industry level, much of our time spent is in this part of the analysis, where we look at the industry financials, we look at in-depth government data, we rely on individuals and experts at colleges and universities, and even proprietary data is all brought to bear to come up with what we think is the direct effects. And that is where the majority of our work in this type of a process takes place. Unfortunately, with critical minerals and the Williston Basin in particular, we don't have a lot of those traditional sources, and we don't have a lot of those traditional means to develop the direct effects. But what we are doing is we're still applying the same methodology where these direct effects then feed into economic modeling. And in this particular case, we're applying input output analysis. That particular type of analysis will generate estimates of those two other types of economic causes that we just talked about, indirect and induced. And when we combine the direct, indirect, and induced, how are we describing what will take place? And this is where we're looking at things like labor income, employment, business volume. These are more macro measures of the effects that something might have on the economy as a whole. So let's take a closer look at an example. We had this new company. Several of the brain trusts at the ERC went together and they created Mega Minerals. Mega Minerals needs transportation, so they are going to buy a car from the local dealer. So Mega Minerals now owns a car, but now the local car dealer has received payment for that product. What happens after that payment is received? That local car dealer uses some of those proceeds. They themselves have to purchase inputs or pay expenses. And you see here a short list of some of the more common ones. It's not exhaustive, but you can see that depending upon what they're acquiring or what they have to pay for, it affects different parts of the economy. We call them sectors. So in this particular case, they're going to have to replace their inventory. They have to have something to sell. So that affects manufacturing and transportation. And you can see on down that list that there's a sequence of here's the bill and here's the economic sector that's involved. So that's an example of the indirect economic effects. Really, what that is a transference of business to business purchases and sales. And each of those sectors, of course, affect other sectors. So let's talk about the induced economic effects. This would be consumer to business or household to business. So Mega Minerals has lots of employees. They're all getting paid. So there's a payroll there. And let's go back to the purchase of the vehicle. Some of the proceeds from that purchase of the vehicle, believe it or not, actually go to some of the employees of that business. Well, what do those employees do with their earnings? They're going to consume goods and services just like the employees of the Mega Minerals are going to do so. You got phone, mortgage, groceries, dining, clothing, daycare, entertainment, medical vehicle, all of the things that are consumed as an individual or as a family or as a household, they also affect economic sectors. And some of those economic sectors are different than the ones that are affected with the business transactions. And so when you pay your phone bill, what happens? It affects the communications sector. What does the communications sector do? They have to acquire inputs for them to be able to put their phone services on. And so effectively, this works its way through the economy as these what we call demand shifts work themselves through until that demand is satisfied, or in some cases, that dollar chases an input or a good that's no longer available and it quits circulating. So, to qualify what we're doing here, to just make sure that we're kind of on the same page, is that when we talk about indirect and induced, really what we're talking about is the supply chain that goes backward from the form of activity that we're discussing. So in this case, let's use an example of a graphite plant. This graphite plant needs to purchase inputs to operate: utilities, communications, raw ingredients, all of those types of things that it needs to purchase. Well, those economic sectors that apply those inputs to the graphic plant, those also need inputs. And so this is that chain that takes place as we go backward from the plant. What this analysis doesn't do is that if all of a sudden we're producing tons of graphite per year or tens of thousands of tons of graphite per year, it doesn't tell us that we're going to have two more plants that process it into graphene or that ultimately we're going to end up with a large battery plant. It doesn't do that. To do that, we would use similar processes, but it's another analysis. And so just to be clear that we're looking at, if we establish these businesses and these opportunities, what happens with those businesses as they operate in the state? What type of employment response can we see when we look at indirect and induced effects? Okay, so essentially, um, Dan created very, very effectively created these arrows to show that as a demand in one particular segment of this supply chain changes, it flows through to all these other sectors that are affected. And so this graphite plant, if we're going to build a new graphite plant, that's a new demand in the state. And that demand then suggests that we're going to need some more inputs, and those inputs are going to come from sectors, and that sector's output is actually this graphite plant's input. And that relationship holds as we go backwards through all the economic sectors that would be involved with this. And so that flow diagram just kind of emphasizes how these sectors become linked and how a change in one part of the economy can influence other, what would seem to be unrelated sectors of the economy. So let's look at some opportunities, and we're going to apply some of these processes and some of these techniques to a number of opportunities. I listed some here for discussion. Mining and extraction, I think we can bypass that for now. I don't think we've got the geology that's really going to make that a viable option for North Dakota. Processing of ore, yeah, actually, there is work in progress to look at taking nickel ore out of Minnesota and moving it to Beulah, North Dakota, and processing it. So maybe there's an opportunity there for North Dakota to position itself so that we can be a secondary processor of some ore. And Nolan discussed very effectively in the presentation with the last webinar that there are opportunities to extract rare earths from lignite coal that's mined. And there's also opportunities then to take those concentrations and add additional secondary processing. So let's look at, we're going to include those. In situ mining, yes, we have coal seams that are not being accessed or are not accessible with open pit mining, but could very well be accessed with in situ. Primary extraction from fly ash, we recognize it as a potential, but I didn't include it here. We know that a lot of that fly ash is already in a product stream. And I think that the technology to work with that is something that we'll put off until a future evaluation. And then the graphite and graphene manufacturing, I think that's a logical extension of what we know to be a possible output from the lignite coal. So with those particular options, there is a host of things that we could bring in to bear on the analysis that we're gonna push to the side, and those are permitting, markets and trade, policy, technology, business economics, and private investment. These are all questions and issues that we're all working with and trying to address as the U.S. looks to develop its own critical minerals industry. And we're also wrestling with those in North Dakota. This type of analysis is not going to get that deep into how a market might affect the viability of being able to extract a rare earth from a lignite feedstock. We're not getting into those types of details. Also, another element of this analysis that bears mentioning is that there is a synergy and there is a connection with some of these activities and opportunities with the lignite industry. And we're not going to pull that into the analysis for this particular time, recognizing that it's there and there's a chance for some synergies and maybe some implications of what happens with the lignite industry might affect the viability of some of these other opportunities. So here's what we did. I went out and I found as much relevant information as I could to place a job number and look at whether we would be talking about one operation or multiple operations. And we'll settle on those 5 opportunities, as I call them. And we're looking at direct employment to operate the facility as has been described by other sources. And so had a conversation with the folks at the Beulah Job Development Authority, and they tell us that Talon Metals or Minerals is looking at employing 150 people to do secondary processing in nickel ore. So that's kind of how we came up with those direct job numbers. In situ mining for lignite coal, to my knowledge, that's not occurring, but we can draw parallels with that from uranium mining that was taking place in Nebraska and Wyoming. Nolan did a very good job of explaining what was involved with the primary extraction of lignite and secondary processing. So we worked with him and his folks to get estimates of the direct jobs. And the graphite and graphene manufacturing, this is very interesting. This is something that we haven't discussed yet on this project, which is what's occurring outside of our region, what's already happening in the United States. Well, there happens to be 2 rather large graphite manufacturing facilities that are in various stages of development. One is Anvion Technologies, that's in Georgia. They're looking to vertical integrate with solar power. And then there's the Alabama Graphite Products. That will be the largest manufacturing facility in the US when it's completed. Those 2 projects are looking at 100 employees and 400 employees, anywhere from 7,500 tons to 40,000 tons per year. So I picked someplace more conservative towards the bottom line, and that's where we got 130 jobs to set up a graphite manufacturing plant, and that would be at 10,000 tons per year. So how do we translate what we just talked about into employment? Well, traditionally the analysis we would go to industry and partners and say, what do you pay your folks? Where do they live? And we would work with information that's already existing, relevant and timely to North Dakota, and that would form the basis for much of our analysis. Unfortunately, we don't have that as an option. In fact, we don't have that pretty much anywhere in the US yet. So what I did do is we have a system called NAICS, North American Industrial Classification System, that codes everything that is consumed and produced in the US economy, gets a number. And so I use those numbers to match up existing operations that would be a reasonably close fit for the opportunities that we're discussing for North Dakota. So I pulled data from the US and come up with a payroll number. So now we know what we think these particular opportunities might have for a gross payroll. And I'll explain just in a little bit why that's important to know. And we used information from existing economic sectors to come up with the next important element, which is what will these industries be spending their money on and where will they be getting their inputs? It's a critical piece of the employment puzzle when we look at something at an industry level. So basically, I looked at input purchases in these sectors and matched them up with employment, and then matched that employment to the jobs that we thought we're going to have. And voila, we get a production function. What I mean by that is we have an idea what is purchased and where it's purchased. Well, that's great at the US level, but that doesn't help us at the North Dakota level. So I said, what if we were to put this into a range, and let's say that North Dakota is not well equipped to supply these new opportunities with what they need for business inputs and production inputs. And then I said, conversely, I said, what if we are in a good position? So I use a 20% and 80% of what they need for inputs will come from North Dakota. Now, I'll show here in a second that there are some sourcing of inputs that we do not actually produce in North Dakota. It's not a quantity issue, they simply do not exist. And so our analysis with those produced no employment. But that's food for thought for further on in the discussion. So let's go back to those 5 particular opportunities, and we have payroll estimates. These are anywhere from single digit millions to double digit millions. And we're looking at production inputs, anywhere from 15, 20 million up to 100 million. These are annual values. Now, with the payroll, we're not going to suggest that for processing a rock ore that North Dakota is going to see $17.7 million worth of consumer goods and services purchased. Modeling will take taxes out of that, will take investments out of that, will take expenditures that are made out of state out of that. And so there's some adjustments that go on that, but we need to have that. That's a starting point for how these systems work. Production inputs, same way. Now we got an idea of the dollar volumes that are needed. We've included the NAICS codes just in case someone wants to go out and see what we thought was the best fit. Knock yourself out. The NAICS manual, by the way, is 900 pages long. And I fully recommend you read it if you have a trouble sleeping. It is great reading material. So potential statewide employment. Here's now where we applied what we've talked about to actually look at some numbers. So let's take a look at processing nickel ore. We see that there's a pretty large swing between our low and a high estimate with respect to indirect jobs, and a reasonably high spread with how those input purchases might affect induced employment. When we look at direct payroll, let's just talk about processing nickel ore at this point. That's just tied to the 150 jobs. We did not put in another series of scenario driven what ifs with this. When we look at that as an opportunity for North Dakota, what we're looking at is potentially a doubling of the direct jobs to a number that is 3 to 4 times what the direct employment is. And that is the range there is being tied to whether or not we can supply that particular type of an operation with the inputs they need, and how those inputs would then trigger employment growth in North Dakota. And so we can look at these numbers in the same way as we go down that list, looking at primary extraction of lignite coal and secondary extraction. They do not need to be linked, but in the case of what we're looking at here, the spread is not as large, the induced effects are not as large, and as a result, there's less, how do you want to say it, uncertainty with what those particular types of operations might mean to the state in terms of total employment response. In situ, by far the lowest potential job creator as we've modeled, and the graphene graphite, that one, believe it or not, comes in very similar to other manufacturing processes that we've looked at in the state. So if we were to look at this holistically, what are we talking about if we had all of these operations in the state and we hit somewhere in the middle with what we could expect for employment? We're talking 700, 800 direct jobs. We're talking 1,200 to 1,400 indirect jobs, induced jobs. So we're probably looking at something, in that 14 to 1,500 job range if we had all of those operating at a capacity where we could provide a meaningful amount of their inputs, goods and services that they would need. So when we look at this issue of whether or not we're going to capture employment through providing what these particular rare earth and critical mineral opportunities would need, I looked at this on an economic sector basis. So that's generally how the information's gathered. And when we talk about industries, we talk about things at an economic sector level. So how many sectors are needed to satisfy the needs for these particular types of opportunities? In all but one case, it was over 100 sectors will provide some type of inputs to these operations. And looking at these production functions, and again, these are based on national data, but given that we don't actually have anything occurring yet, we haven't actually dived into, what specific technology would require for what specific type of inputs. I think this is a fair assessment to look at how are we positioned in North Dakota. When we look at the number of sectors that are not available in North Dakota, anywhere from, a dozen and a half up to 30. And so that's a pretty meaningful number when we start looking at whether or not we're going to be able to reap the benefits of these particular operations in terms of additional jobs outside of the direct jobs that are going to be associated with the actual facilities. When we look at what type of sectors are we short in, this comes back to this issue of backward supply chain, and most of those are in manufacturing. We simply are not producing the goods and services. Well, I shouldn't say service. We don't manufacture a service, but the goods that are going to be needed for a lot of these types of operations, we don't even have them available yet in North Dakota. So that raises the stakes then in terms of What are we looking at when we want to go after an opportunity in North Dakota? Are we looking at landing the direct facility and we think we're just going to import its goods and services, or can we as a state find a way to fill that gap? So I'm going to change speeds a little bit at this point. And so talk a little bit about workforce. There is probably fewer topics hotter in North Dakota and elsewhere in the country right now. In North Dakota, I would say it's employment and taxes, but workforce is right up there. When we look at the national mix for the mining industries that we think are a reasonably close fit at this point with what we're talking about, almost 70% of them are going to be in some type of extraction based job, whether it's a construction related job, repair and maintenance of the equipment, production jobs. The remaining 30% of what might be needed is going to be into more of the more technical type jobs, engineering, physical sciences, management, administrative support, computers, that type of thing. But the reason I put this in there is I think that we need to pay attention to this as a state, because these are based on technologies that may or may not be a good fit for the technologies that we're proposing are going to be used to extract critical minerals out of North Dakota. So traditionally, this is what we can expect. I would expect those numbers to shift a little bit as we get more information on the actual technologies that are going to be applied. Now we're going to look a little bit more downstream from the actual separation of the critical minerals from its feedstock. We're looking at some additional processing. These start to move us into manufacturing sectors. This is, again, the government's way of tracking how all this stuff takes place. It's not something that I created, but looking at these three manufacturing sectors, what's the difference that we see in the workforce? Okay, now production jobs. These would be jobs inside the facilities, moving product along, monitoring flows, doing that type of stuff. Those are the jobs that would be needed. Transportation comes in. And then you can see that there's a little bit higher percentage with business, sales, management, and things that go with that. So we're looking at a slightly different mix. Again, I think I'm putting this in here so that we think about what it's going to take to fill those jobs if we are to land that, and that there's going to need to be a host of skill sets that go into making sure that we can provide the employment that these opportunities might need. So we covered a lot of ground. A lot of what we talked about is not nailed down, it's not concrete, but we do have a process in place that we can look at on how these types of opportunities might affect the state. So the biggest variable or unknown at this point, I think, and we tried to demonstrate that using national data, would be, can we as a state supply most of what these new projects will need? If we can, I think we're going to see a more robust employment response. It's going to be much better for the state, more jobs, more tax revenue, more of all the things that we're looking for to bolster the economy. However, I think that's left to be seen. How well we're going to be positioned for that. Some of that will be more understood as these technologies become better fleshed out, and we understand what the particular how you want to say it, what the particular inputs are going to be. If we move to chemical processes as opposed to mechanical, I think we're going to be in that. It's going to be tough to capture a lot of that because we just do not have the chemical manufacturing to handle what those opportunities are going to be looking for. Least variable, and this we have a lot of data on. When we introduce high paying jobs in the state, the linkage between the personal spending of those employees and jobs from induced activity is very solid. We have data from the oil and gas industry. We have data from the lignite industry. We have data from the ag industry. I think that's probably our least variable effect, is when we introduce these processes and they have good high paying jobs, and hopefully there'll be jobs that will be occupied by people that are residents of the state. We're going to see some job response from that, and I think that'll be more predictable. Wild card, as I mentioned earlier, we know there's a link between much of what we discussed and the lignite industry. Whether the development of that triggers an employment expansion within the lignite industry is unknown. Whether these extensions of lignite ore can make the lignite industry more resilient, all of those questions remain in kind of the unknown category. And so I think there is the potential for some of this to even strengthen the state through having a bolstered lignite industry. And what that might be is food for another analysis. As I mentioned earlier, this particular analysis is limited to looking at feeding these jobs or feeding these opportunities with what they need to operate in North Dakota. It doesn't tell us how far up the supply chain we're going to have in terms of additional opportunities. Now, I'm gonna say that that's a good point for us to drop the discussion of what we're gonna have for jobs and what we're not gonna have for jobs. I think some of those questions we're going to be putting the cart in front of the horse on, because until we can figure out what we're actually likely to land in North Dakota and whether or not the business is feasible, the market opportunities remain robust enough that we can attract private capital, and so on. We have a policy to protect our domestic industries. All of those unknowns become a little more in focus. I think if we extend this discussion too far, we're probably becoming far more speculative than we need to be. So we know the opportunity is real and the employment that goes with that is real. We've seen that in a number of examples. It's occurring elsewhere in the US, and some of the in-depth studies that are even occurring at UND are showing that the job potential here is very real. Is it going to be transformative at the state level? You know, it's possible, but I think it's highly unlikely. And the reason for that is that when we look at the size of the state economy and we look at the relative size of what these opportunities mean, the state has 440,000 wage and salary jobs and another 120,000 sole proprietors. So we're talking about adding 1,000 jobs or 1,200 or 1,500. We're not going to move the needle very far at the state level. But when we look at these at the local level, I think they could be critically important. And looking at where they're going to be located, they're going to be located probably in coal country. And what's the sole driver of the economy in the coal country? It's coal industry. So if we can provide another avenue to diversify that economy in those localized areas, I think these opportunities can be very important at the local level. Finally, I'm going to throw this out there. At this point, no unicorns and rainbows. We have opportunities in the state. They're very real, and I think we can add employment. But are we going to put China out of business? No. Are we going to transplant Silicon Valley to North Dakota because we have a couple rare earths that we can provide? I don't see that occurring. As is what is already happening elsewhere in the country. Some of these graphite plants, some of this stuff is tying in with businesses that are already in those locations. We're going to have to keep an eye on what's occurring outside of North Dakota as a barometer of what may or may not be feasible in North Dakota. And so at that point, I'm going to stop talking, and I guess we'll either open it up to questions. We have a contact slide. I invite anybody to reach out and provide positive or unpositive comments if you desire. But I think there's some concluding remarks that John's going to have that we can tie this all up with. Thank you.
Yeah, thanks, Dean. Appreciate all of that. And again, it's very difficult to get started on doing scenarios on an industry that's not yet formed. But you got to start somewhere, and I think this is an excellent start and a good avenue to begin discussions with. So I've got just a couple more slides I'll go through, and then we'll open it up for questions. Again, just want to say thank you to the sponsors of the CORE-CM program that provides the opportunity to give these webinars. In general, the NETL CORE-CM program is trying to address five issues. One, they want to catalyze economic growth. Two, again, like what we're discussing today, job creation in energy communities. Three, making sure that those communities aren't left behind. Four, again, looking at the domestic production of rare earth elements and critical minerals, which leads into five, which helps strengthen our national economy and helps promote national security. If you go to the next slide, just in general, there are 13 CORE-CM Initiative teams across the U.S. We are number 6, the nice gold image in the center there, covering North Dakota, parts of South Dakota, and Montana. and there are neighboring initiatives in Wyoming and Utah and others in New Mexico. This is the overall project team, and this goes beyond the sponsors. You'll see there are a lot of entities listed here, whether it's direct project team, people that are interfacing on the project every day, our sponsors, and also entities that we collaborate with, which are also other CORE-CM teams. And you'll see many of them listed there on this slide. There is a lot of interaction going on these projects across the U.S. And a thank you to everyone on our team that does this. Just briefly want to go through the disclaimers here, of course, for Department of Energy. Our thoughts and conclusions are our own and are not necessarily indicative of what DOE is thinking or saying. And any products or otherwise things that we're promoting are not being promoted by the Department of Energy. Same type of discussion for the North Dakota Industrial Commission. We're not speaking for them. Our opinions are our own. Finally, or almost finally, want to point out real quick that coming up next month in Bismarck, we will have our second annual Critical and Rare Earth Elements Symposium discussing the Williston Basin and beyond. Now, last year we talked almost exclusively on the CORE-CM program. This year it's being opened up a little more, and you'll be hearing discussions on other work that's being conducted in the state, especially work that's being done through the College of Engineering and the Mines at the University of North Dakota. So October 9th, reception in the evening. The symposium is the day of October 10th. There's a QR code there, which takes you directly to the site for signing up for this symposium. And I'm pleased to say that our keynote speaker is going to be Dr. Jessica Mullen from NETL. She oversees all the CORE-CM initiatives across the U.S. And she's going to be speaking at this symposium as well. So I encourage you to consider going. We will be having another webinar coming up probably late in November, coming soon. We're still working through all of the particulars on that, but be looking for announcements for that next webinar. Like I had mentioned at the beginning, we do have a website for the CORE-CM program, and at that site you can find the recordings for this webinar and all of the previous 4 webinars, along with information about the project and additional information about critical minerals. There's the QR code for that, and there is the listing of our website. And with that, I'll thank everyone for paying attention to today's webinar, and we'll open it up now for any questions that you might have. So feel free to throw the question into the chat, or turn on your microphone and then just jump right in with the question.
Hi, this is Sue-Ann Olson speaking. Well, you've commented in the past, just how far out, how many years out do you sort of anticipate it taking for some of this to really start happening economically? We're there, we've got technology actually start recovering these rare elements.
Yeah, Sue-Ann, that didn't come across, at least for me, so clear. But what I believe, in essence, you were asking was, how far out do we think or project that there may be an industry in the Williston Basin? Is that what you were asking for?
Yes. Yeah.
Yeah. Dean, do you have any initial thoughts on what you think a good projection for that is? Certainly on my side, on the technical side, things are in progress and wheels are in motion to get industry started, but it's going to be several additional years from now before components of this, outside of maybe what Talon is working on, to really get components of this supply chain really moving. And certainly we are thinking in the terms of a decade or more, but I don't know, Dean, what are your thoughts on this?
Well, I think we've got a coalescing of a number of unknowns that are going to have to come together at, going to have to become better understood before we can start throwing businesses on the ground and claim that we have an industry. I think one of the critical things here is going to be, can we attract private investment if there are no domestic safeguards for us against what China might do? If I'm sitting on the sideline and I want to invest in a rare earth or critical mineral plant, I do not want to get squashed by China. Will there be a policy response that can address that? I don't know. We know the markets for rare earths are solid, and we expect for many of those critical minerals that, in all intents and purposes, every source you look at suggests that future market demand is going to greatly expand from what it is now. So I think that's a positive. We know that we're going to have more electrical-based consumer products, industrial products. That's just going to continue to grow. So I don't think there's any questions with that. There's also going to be the growth in technology, and that's where the engineering and the geosciences come in. Is, will there be improvements in the extraction processes that make these opportunities more economical or more, how do you want to say it, more resilient to changes in market prices? There's a bigger margin involved with that. So, essentially there's a lot of feasibility work that needs to be done. There's a lot of policy work that needs to be done. I do know from an example that in the conversation I had with folks in Beulah, that the nickel refining and concentrating activities that they were talking about, if that gets permitted in Minnesota, they've already got a contract with Tesla to supply Tesla with all their nickel. So I think those are examples of some of the things that we can expect to start to see that will need to take place before we see investment in some of these facilities.
And conversations that some of us have had with producers, or at least the middle market processes in some of these production streams. Many have indicated, just on the sheer thought of maintaining consistent supply of raw material, they are very open and welcome to domestic sources and domestic production, if for nothing else, just to keep that security in mind. So certainly, as we're going through and looking at least within the Williston Basin of what's available, it certainly looks like that there are a decade plus potential of industry here, probably several decades, depending on size, particular elements of request and in question. So this could be a moderate term production system that is maintained. And then if we're looking at conjunction with other regions in the US, and we start to say, looking at like a hub and spoke style of business, it may be that many of these areas start specializing in one specific component of this supply chain, and we're all helping each other on a more national scale. And so then that helps prolong this even longer into an industry type of layout. So
one additional thing I would throw in there, John, would be is that we know the environmental interests in this country can be very powerful in preventing certain things from getting permitted. A lot of the technologies that are being evaluated are not the same technologies that we're seeing being used in other countries that are very detrimental to the environment. And so, having processes that don't require decades of mitigation in the courts, I think is a positive, but still permitting can be a wild card. And there are some best laid plans that show that projects can be economical and they can meet national need, and they don't get permitted. So, that's another wild card that we're going to have to work through.
anyone have one final question? Anything else we can address? We're coming up to the top of the hour. All right. Well, again, thank you, everyone. It's greatly appreciated that you attended the webinar today, and we look forward to seeing you on the next webinar coming up in November. All right. Thank you, everyone.
Yeah,
Thanks,
thank you.
everyone.